Let's talk about a certain type of problems from section 5.5 in your textbook where we need to model linear equations, model using linear equations. So an example that I want to look at in the textbook is on the same section, 5.5, on page 275, number 22. And instead of doing the same exact problem, we're going to take a look at an exercise that we would typically see in our homework. So we'll take a look at exercise number 22. And in this problem, the life expectancies at birth of people in some country are shown in a table for various years. And then they say let L be the life expectancy, so that's the second row, in years, at birth in years of a person born T years after 1980. Using a graphing calculator, draw a scattergram of data and choose the correct answer below. So what I want to do is I want to take a quick snapshot of this, and we're going to do the table on the calculator, but we're going to reconstruct it a little bit, or rearrange the table. So our idea is to make an XY table, but instead of an X and a Y, we actually have T and L for the life expectancy. So remember though that this is 1980 minus whatever each of these values are. That's what your T is. Or I'm sorry, this minus 1980. So the first one is going to be 0, and in 0 years, T is equal to 0, where average life expectancy is 72.7. And 1986, that's 6 years after 1980, 75.8. 1990, which is 10 years, 74.5. 1995, that's 15 years, 76.9. 1999 is 19 years, 77.1. And 2003 from 1980, that's 23 years from 1980, that's 78.5. Okay, the next step is to put this in your calculator. So let's take my calculator out, and I basically want to copy this table. So turn your calculator on, and we don't need to be at the home screen. What we need to do is go to Stat. So let's clear this, and hopefully I'll not make too many mistakes during the process, so you can see the keystrokes here on the side. Hit Stat, and we're going to select number 1 for edit. We're going to edit a table. Now my cursor is in L1, and the first element in L1. And so what I want to do is I want to hit the up button, and I want to clear that out. Now press enter. I might as well clear out the second table too, so I'm going to right arrow and up arrow to get to L2 and clear that again. And it's kind of important to make sure that your lists are clear before you type in, because if there's any extra values in your list, then it's going to give you a dimension error. So for my t values, I'll use my t values for L1, so that is 0. And I'll just press enter after each number. 6, 10, 15, 19, and 23. So 1, 2, 3, 4, 5, 6 elements in my list. Now if you look at my cursor, I'm in the 7th element, but it's blank. So that means I have 6 elements in the list. I'll right arrow to L2 and put in the values there. 72.7, 75.8, 74.5, 76.9, 77.1, and 78.5. And so just want to make sure that the lists are matched up. I can move my cursor off to the side here. So I see that I have 6 elements in both lists. I can double check my calculator versus the list that I have written down on paper, and so that looks good. So now your list is all set. So what I'm going to do now is I'm going to clear the screen, the keystroke history, so that we're ready for our next step. So whenever I want to go back to the home screen, I usually press second and quit, or second and mode, to get to the home screen. Next thing I want to do is I want to plot the data points. So I'm going to go to second and the y equals to, which is really a stat plot. And right now I see that all my plots are off. And if they're not all off, you may want to turn it off by pressing 4. I'll do that. And then press enter. Because you only need one plot on. So let's go back to stat plot. And for the first one, I'm going to select number 1. And then I want to turn this on. So while it's blinking on the on, right now it's off. So I'm going to, while it's blinking on the on, I'm going to press enter. So now it's on. I'm going to right arrow down, or I'm sorry, down arrow to select the type of graph that I want. Now these are all the statistics plots that are available for your TI 83 and 84. I'm going to choose the first one. That's the that's graphing scatter plot. Your X list is L1, your Y list is L2. It's usually set up that way. And then the marker that you want, this is the easiest thing to see, is a little square marker. So we're all set. Now we want to graph it. And here's another trick to graphing. I'm going to go to zoom. And I'm going to look for zoom stat. Now it's down below, so I'm going to use the up arrow because it loops around. Nope, I guess that's not very good. I am going to go down. And depending on what kind of calculator you have, I have mine on the 9th option. Some people might have it in a different place, but look for zoom stat and press enter. And this will graph your scatter plot. Now it looks like I have some lines, some extra lines popping up here. That's probably because I have some other functions in my y equals to. So let me go over there and clear that out. So I press y equals to, and it looks like I have 2 functions here. Maybe 3. So 4. So I'm going to clear all that stuff out. So what I do to clear it out, I just go to the y equals to or y3 equals to or whatever, and I press clear. And then I hit the up arrow, clear. And let's just clear everything out. Okay, so I can go to zoom and zoom stat again. And I think I remember it was number 9, so I'm just going to hit 9. And here's my graph. So this is a scatter plot. And if we look at the assignment that we were looking at, it looks awfully close to B, so I'm going to select B. Okay. Now the next one is to find an equation of the linear model to describe the data, and choose an equation below. So there are several ways to do this, and one way is to use a calculator to use a linear regression. But instead of doing that, what we're going to do is, since we have a choice of them, let's check them out and do maybe a process of elimination. First of all, let's go back to our scratch work. Your y value is L, or it's called L, and your x value is t. So you know how you write your line as y equals mx plus b. Your line would be L is equal to m times t plus b. So your L is your what we would call our dependent variable, and your t is called your independent variable. So in terms of scratching out choices, I can see that choice number C is out of the question already. Okay, so I'm not going to select C. All right, now there's 3 left, and y equals mx plus b. M is your slope. And if you look at the data that we have in our calculator, it looks like our slope is going upward. So slope, line going up, means that the slope is positive. So looking at that, I can actually now eliminate this B choice with a negative slope. So now it's between these two. Now I know that the slope is positive, and now the last number here is the y-intercept. So the y-intercept here for D is negative 73. The y-intercept for A is positive 73. Well, if you look at the graph that we have here, it looks like whatever line we're talking about has to have a positive y-intercept. So just by process of elimination, it looks like we can choose A for our answer. Now, another way to do this, before we get to this last one, is to look at the graph, or take out your calculator again, and as long as you have the data already set up in your L1 and L2 list, you can do what's called a linear regression test, or a linear regression problem. So that's what we're going to do. So I'm going to clear the history here and go to Stat, go to Calc, and I'm going to go to number 4 in my calculator, at least, where it says LinReg. That stands for linear regression. And usually you would type L1 and L2, but that's the default. So I'm just going to press enter again. And here I have my linear regression. So what is this saying? Again, my y, here they changed the letter. Instead of the slope being m, it's a. That shouldn't be a big deal for us. So I'm going to write y is equal to a, which is positive 0.2254 times x, plus b, which is 73.174. So this is a good linear regression, or a good equation of a line. Now, if you compare it to the choices that we had earlier, it's not exactly. The choices that we had earlier is 0.21 t plus 73.5. So it's not exactly the same thing, but it's quite different from the rest of the other choices. So you could do a linear regression calculation since you have the thing in your L1 and L2. So that's just another way to find your regression line, your line that models the data. All right, now back to the last last question here. Draw the line and a scattergram in the same viewing window. So you can kind of tell that, again, by process of elimination, A is not good because the line's way below. D is no good because it's negative. And C looks like it goes a little bit too low, so it looks like B is your best answer. But I want to show you how to put that in your calculator. So take out your calculators again. And remember the y equals 2 where I had to clear some points or some functions. What I want to do is I want to write this equation that we found in part B. So that's 0.21. Now I don't have a t here, I have to use an x, and the x variable is this button over here. X plus 73.5. Okay. Now I can hit graph, or I can go back and just to get us used to doing the zoom stat, let's go to zoom and zoom stat, which again for me was number 9. So I see that my data set is being drawn along with that line of the graph, and so that looks a lot like B, which is a choice that we found. Okay, but at least you can see the drawing here now. So I'm going to select B. Okay, so another thing that you can do with a scattergram is once you have this function, you can do a trace. Now if I hit trace, if I look at the upper left hand part of the window, I see P1. That's my statistics plot of the data points. If I hit the up arrow, I see y1 equals 2. This is actually the equation of the line that we included. So if I hit up again, it kind of toggles back and forth. So if I look at my point, this is the data point 0, 72.7. If I hit the right arrow, it moves me from one data point to another. So I have 10, 74.5, etc. If I hit the up arrow, this point over here, 11.5, 75.91 is actually a point on the line. And if I hit the right arrow, then I can move my point on the line. Now here's a cool thing. If you want a specific point, like maybe in 1982, I would hit, just instead of moving the arrow of the cursor down until you get close to 2, you can just jump directly to 2 by hitting the number 2 and then enter, and that would bring me on the line where x is equal to 2, and then that'll give me a specific y value. Okay, so this is how you would plot and draw the line and get the linear regression line from the calculator, and I hope this helps.